total internal reflection. Total internal reflection. You have come across the term reflection. Okay, reflection. So bouncing back of light to the same medium. Okay. So in total internal reflection, the object should be present in the denser medium. Okay. When this phenomenon occurs, there is no any loss of intensity of the light. That intensity value remains same. I will consider a interface. Let xy, okay, xy be the interface which separates two media. First, let it be rarer medium and one more is denser medium. For example, our rarer medium is A and our denser medium is glass. Okay, general one example I am doing. There is an interface which separates. So its xy is a line which separates two media. Upper surface is air and lower surface is glass, or it may be water and milk. Okay, and our object is present in the denser medium. Okay, our object is present in the denser medium. O is our point object. O is our point object. Okay, this point object emits the light, and this light travels in the different direction. Okay. So while drawing the ray diagram, what you have to put? You have to put the arrow mark. Okay. If there is no any arrow mark, it will be a meaningless. Okay. Consider first ray. OA is the ray which is normal. Okay, angle of incidence normal. It will be undeviated. Okay, this ray is normal. Angle of incidence is normal. Then refraction will be or reflection will be normal. So this ray will be undeviated from the interface. Next, there is certain angle here. It's the normal drawn to the surface. Let OB be the ray which get incident on the interface. Okay, when a ray of light traveling from denser medium to rarer medium, what happens? When a ray of light traveling from denser medium to rarer medium, what happens? So it bends away from the normal. Okay, this ray bends away from the normal. Okay, one let it be P, Q, R. Here O, Q is the incident ray at this point. So from this value to this, the angle of incidence has been increased. Initially angle of incidence was 0. In the next ray, the angle of incidence has been increased. In the next case also, once again from here to here, from the angle OP to angle OQ, the ray OQ, the incident value also increased. Again from angle OR from here to here, angle of incidence once again increased. Okay. So what happens? At certain value, the refracted ray or the reflected ray grazes the surface. This value will be nothing but our 90 degree. Okay, at particular angle of incidence, at particular angle of incidence, the refracted angle will be 90 degree. Okay. Next, if once again the angle of incidence has been increased. When angle of incidence greater than this value, okay, if it is IC, if this angle value is greater than this value, then the reflected rays, incident rays, totally reflected back to the same medium. Okay, this IC is nothing but the term critical angle. Critical angle. Once our incident angle is greater than the critical angle, then reflected ray, or it is totally reflected back to the same medium. Okay. So, or we can define the term then total internal reflection. When a ray of light is traveling from denser to rarer medium under certain conditions. Okay, under certain conditions, the incident rays totally reflected back to the same medium. The incident rays totally reflected back to the same medium. So that condition is called as what? Total internal reflection. Okay. In order to obtain this condition, obtain this phenomenon, there are two conditions. So it's the important question which is usually asked in your 2 marks or 3 marks. Define the term total internal reflection and write the condition of total internal reflection. Condition of total internal reflection. Okay, first and foremost condition is that ray of light should travel from denser to rarer medium. Ray of light should travel from denser to rarer medium. First and foremost condition is that light rays should travel from denser to rarer medium. Okay. Second, one more condition. The angle of incidence should be greater than the critical angle. The angle of incidence should be greater than critical angle for a given pair of medium and given wavelength. Okay, so what's the condition? The important concept it has for 2 marks. Okay, the condition of total internal reflection is that foremost condition is that the ray of light should travel from denser medium to rarer medium. Okay, second condition is that angle of incidence should be greater than the critical angle. Okay, the value of critical angle remains constant for 2 given pair of media. Either it may be water, air, glass, air, water. Okay. Next, there is one relation between the critical angle and refractive index. Okay. There are certain relation between speed of light in another medium with respect to the value of refractive index, that is real refractive index, absolute refractive index. Okay. You will get one more relation which relates the refractive index and critical angle. Okay. I will take the rarer medium, that value as n1, denser medium as N2. Okay. Since our ray of light is traveling from denser medium to rarer medium, our ray of light is traveling from what? Denser medium to rarer medium. So the ratio sin I by sin R is nothing but N1, 2. Okay. Sin I by sin R is N1, 2, which is nothing but N1 by N2. If I interchange, I will get the generalized form of Snell's law, that is N2 sin I equal to N1 sin R. Okay, N2 sin I equal to N1 sin R. In this example, okay, in this case, our rarer medium is A. The value of refractive index, that is N1, I will take instead of 1.0003 or 29, I will take directly N1 as 1. For the critical angle value, the refracted ray, R value is what? R value is equal to 90 degree, and instead of using I will use the notation IC. In some of the book you will get instead of IC simply C. Okay, IC can also be used, that's the critical angle, and C is also the critical angle. Okay, anyone you can choose. And to the value of refractive index values of denser medium, instead of N I will write the term N. Okay, if I substitute all these values, how can I write the equation? N2 is replaced by N sin I sin C. Okay, I will use the notation C. N1 as 1, sin R is sin 90. Okay, what's the value of sin 90? Okay, 1 it is. And sin C equal to what? 1. And sin C is equal to 1. That value you get, N is equal to 1 by sin C. Okay. Or if I write in terms of critical angle C, it will be sin inverse of 1 by N. What I can say, if the refractive index value is high, critical angle value will be less. That also once again inversely proportional. Okay. So the relation between critical angle and refractive index, that is N is equal to 1 by sin C. Okay. In the next class, I will explain the applications of total internal reflection.